Hello class, my name is Jared Mosoti from Mount Kenya University, School of Business and Economics. I am facilitating Financial Management 1, BAF2104. Our topic of discussion today is capital budgeting. We go straight to understanding what capital budgeting is. Capital budgeting means the process of planning expenditure whose returns are expected to extend beyond 1 year. That's the definition according to Weston and Brigham. We can also say that it is the firm's decision to invest its current funds in activities that are expected to yield cash flows in future. Why is it important that we do capital budgeting? Capital budgeting decisions will affect the profitability of a firm. Poor decisions will affect adversely the profitability of any firm. Good decisions will positively affect the profitability of any firm. Then capital budgeting involves huge amount of money. Once invested, this money may not be reversed. This means it is very expensive to reverse the effects of poor decisions. Then one other thing is that financial investment decisions involve the future. And we all know that the future is uncertain. And then we know that most firms have got scarce resources. And then they are going to commit the funds over a very long period of time. This therefore means that before committing the firm's funds, it's important to plan before going on with the projects. Then what are the objectives of capital budgeting? First is to analyze the expenditure, the impact of the capital expenditure on the profitability. Once we have sat down and identified a number of projects, it's important to analyze the impact they are going to have on our profitability. Then the other objective is to fix priorities. It is important to note that many projects are acceptable. But then, once we have our priorities right, we will be able to wisely invest the funds of the firm. Then the other objective is to ensure efficient control of large investments and expenditures. The other objective a firm may have is to evaluate the relative worth of the capital projects. Most projects will be evaluated based on the expected returns. And because of that, capital budgeting will enable us to identify the worth of each and every project vis-a-vis other competing projects. Then, the other objective is to make sure that cash is available for the projects that have been identified. Once we have programs or projects, it's important to ensure that funds will be available to finance those projects. Then lastly, the other objective is to aid long-range planning of the business. Now, what are the types of capital budgeting decisions? The first one we have is accept, reject decisions. These are decisions where a firm is considering whether to adopt a project or not. Capital budgeting will be used to determine the projects to be accepted and those to be rejected based on the various methods that we are going to discuss in our next section. Then we have mutually exclusive project decisions. Mutually exclusive project decisions involve competing projects. This is where a firm has 2 or more projects that qualify for investment, but the firm has to decide which one of the firm has to be invested in. This means if you invest in one project, you will not invest in the other. And therefore, capital budgeting comes in to identify the most viable project among the competing projects. Then we have capital rationing decisions. Capital rationing occurs in a situation where a firm has several qualifying, viable projects and limited funds. The firm has to decide how the available funds are to be invested or shared among the viable projects. So in capital rationing, we are actually determining how to share the available funds among the projects that qualify. Now we go to the capital budgeting methods. As you can see, we have 2 sections in our capital budgeting methods. This is because they are broadly classified into 2, where we have the traditional methods and we have the discounted cash flow methods. The traditional methods are also referred to as the non-discounted methods. In this section, we will have the average rate of return, the ARR. Then we are going to have the payback period method. Then, in the discounted cash flow methods, we have the net present value, the NPV, the internal rate of return, IRR, and we also have the profitability index method. We start by looking at the average rate of return, the ARR. ARR is equals to the average annual profits after tax and depreciation divided by the initial investment multiplied by 100. Now, when we talk about the average annual profits, we mean the profits the project is expected to yield or generate over its useful life. Alternatively, we can also have the average annual profits after tax and the depreciation. You divide by the average investment. When we use that formula, the average investment will equal to total investment you divide by 2. Let us use a very simple example to show how the average rate of return works. If we have an initial investment of 5 million and it is expected to yield returns of 300,000 annually, then our ARR is going to be 300,000. You divide by 5 million, you multiply by 100. In our case now, our ARR will be 6%. If we have 2 or more projects, then what we do, we compare the IRR of the 2 or more projects. The project which has the highest ARR is the one we invest in. The next method we are going to look at is the payback period. Payback period, also known as the payoff or simply the payout method. When we look at the payback period, we consider 2 types of projects. There is one project which has uniform cash flows and another project which will not have uniform cash inflows. That means it will not have even cash inflows. So for the uniform cash flows, payback will equal to the cost of investment. You divide by the annual cash inflows. For a project which has uneven cash flows, you subtract the annual cash inflows from the initial investments until your answer comes to 0. So you keep subtracting until the answer comes to 0. Now it is possible that you will subtract, and in the last year, when you are likely to get back your money, the amount of money you get is less than the projected cash inflows. If that happens, then what you do, you assume the cash inflows for the last year occurred evenly. Then the amount still unrecovered will be multiplied by, will be divided, by the cash inflows for that year, then multiplied by 12 months to give you the expected cash inflow. Now, for the uniform, we have one example here. If you have an investment of 6 million and expected cash flow of 500,000, then your payback period will be 6 million you divide by the 500,000, which you'll be expecting every year. That means if you invested in this project, it will take you 12 years to get back your money. Before we go to the next method, in this example, we have used the actual cash flow. It is also possible to use the discounted cash flows to get the payback period. But before we do that, we look at the net present value. Net present value is commonly referred to as NPV. Now, when you look at the word net present value, you focus on the present value of both the cash inflows and the cash outflows. And therefore, we can say that the NPV is the difference between the present value of cash inflows and the present value of the cash outflows. If you do that subtraction and you get a negative answer, reject a project. If your answer comes to positive, you accept a project. If you get an answer equal to 0, then consider using other methods to evaluate that project. I'm going to use a simple illustration here. A cash outflow of a project, that is the initial investment of that project, is 6 million. Then the cash inflows year 1 to year 3 is 3 million year 1, 3.5 million year 2, 1.8 million year 3. You are required to calculate the NPV using the 10% as a discounting factor. Now, for you to calculate the NPV, you require the PV tables, which I know all of you have. So you go to your PV tables. There are 2 tables we have for lump sum and 1 for annuity. You pick the table for lump sum, and then we look at how to get that answer. So for you to get that answer, provide 4 columns. Column 1, you write the year. Column 2, you write the cash flow. Column 3, you write the discounting factor. In our case, it is 10%. Then column 3, you write the present value. And you notice that all the amounts are in thousands. Therefore, if I'm writing 6,000 here, this means 6 million. Then again, you remember, in accounting, we don't have negatives. Where we have a cash outflow or a negative, you put the figure in brackets. And that explains why in year 0, the year when we are investing, our cash outflow is in brackets. And also its present value will be in brackets. Now, if you look at this discounting factor, it tells us the value of a shilling after a period of time. Year 0 is right now. The value of 1 shilling is going to be 1 shilling. And that is why you are seeing that we are having 1.00. If you look at year 1, the value of 1 shilling after 1 year will be 0.9091, After year 2 is 0.8264. Then after year 3 is going to be 0.7513. You have already covered this topic when you are looking at the time value of money. So we have now our columns. These are the cash outflows. These are the cash inflows, which we expect for year 1, year 2, year 3, and that is it. Now to get column 4, you multiply column 2 by column 3 for each year. So you multiply this by this is giving you 6.6 million still. You multiply 3 million by 0.9091, this is giving you that. Then you multiply this by that, this is giving you that. You multiply 1,800,000 by 0.75, is giving you the answer there. Once you have gotten the answers in column 4, you add everything. Now, when you are adding, you should remember that 6 million is in brackets. That means it is a negative. So you add negative 6 million plus all this. It should give you an answer. The answer you get is what we call the NPV. In our case, we have gotten 972,400, which is positive. Therefore, in this case, since we have got a positive answer, the decision of the firm should be accept the project. If you go back there, the rules were, if it is positive, accept the project. Therefore, we accept this project because it has a positive NPV. Method number 4 we are going to discuss is the internal rate of return, which is the IRR. The internal rate of return, IRR. Now, when we talk about IRR, it means that rate of return that will give you an NPV is equals to 0. Now, that tells you that when computing NPV, you require the knowledge of how to compute. When you are computing IRR, you require the knowledge of the computation of NPV. How do you use IRR to select a project? If a project has an IRR higher than the cost of capital, you accept the project. Alternatively, each firm has its set rate of return. Any project that has a rate of return higher than that is accepted. Any project that has a rate of return lower than the set acceptable rate is rejected. So in this case, when we are considering the computation of IRR, we are going to continue doing guesswork until we get that rate of return that we are looking for. Then once we get that rate of return, we compare the rate of return with the cost of capital or with the company's acceptable rate. Now, when you are using trial and error method, you are not going to get an accurate answer. For that reason, there is a formula which is used to compute IRR. For you to use this formula, you must have two answers. One answer must be positive, another one must be negative. So we have IRR is equals to A plus P divided by P plus N multiplied by B minus A. You notice this one is positive, this one is negative. They have been defined here, the variables are defined. We have A, which is the lower rate of return, which is going to give you a positive NPV. Then we have B, which is the higher rate of return, that is going to give you a negative NPV. Then P is the actual amount of positive NPV, and N is the actual amount of the negative NPV. So for us to understand how the internal rate of return operates, we are going to use a simple illustration. A company is considering investing in a machine that is costing 5.5 million shillings and has an expected annual return of 1.2 million shillings and a resale value of 1 million end of year 6. You are required to determine the IRR of that project and also advise the company whether to invest in that project or not if the cost of capital for this company is 11%. Now, as I had indicated earlier, we do not have a set approach to getting the rate of return we are looking for. So what we do, we keep trying various rates until we get a rate of return that will give us an NPV is equals to 0. When doing guesswork, you should be guided by the cost of capital. Don't go very far, too far high or too far low. So in my case here, I have decided to try 10%. When trying 10%, I just draw the same table which we had drawn for NPV. That is, you provide 4 columns. Column 1 you write year, column 2 you write cash flow, and this one is the present value factor and the present value of cash flows. I know now you are conversant with these initials. That is why I have used CF, PF, and CF again. Now, something else. In our earlier discussion, we had used the PV tables for lump sum. And I know you already have the PV for annuities. So you are going to open both the PV for annuities and for lump sum amounts. Because in year 1 to 5, we have uniform amount, we are going to use the PV for annuity. And year 6, we have one off cash inflow. We are going to use the PV tables for lump sum. So if you look at our figure here, year 0, we have 5.5 million and the PV factor is 1. Therefore, the PV of the cash flow will be 5,500,000. Then if you have year 1 to year 5, you go to your PV tables for annuity, go to 10%, move your finger down to year 5. What you see there is 3.791. Multiply that by the cash flow for year 1 to year 5, you should get that figure there. Now if you add, like we did earlier on, you'll be able to get your NPV, which is negative 291.1. We have got a negative answer here. A negative answer means the rate of return we are looking for is less than 10%. So what do? We try a percentage that is less than 10. But again, let us not move very far down because the answer is not very far from 0. Let us try 8. We try 8% now. Like we have done earlier on, we have the cash inflows for year 0, the cash inflows for year 1 to year 5, and then we have the cash inflows for year 6. Now, if you add the figures there, you'll get an NPV of 677.68, which is positive. Since we have got a positive answer, it means the IRR we are looking for lies between 8% and 10%. We go back to our formula, and our A is going to be 8. Our B is going to be 10%. P, the positive answer we have got down here, is 677.68. And our N is 291.1. When applying this formula, ignore the negative. Ignore the negative in N. That means you are going to add 291.1 you add 677.68 without being sensitive of the negative sign. So if you do like that, you will have this, you divide by 677.68 plus 291.1, then the answer you get, you multiply by 10 minus 8, which is 2. The answer you get is 9.4%. So the IRR we are looking for is 9.4%. Now remember we said if the IRR you get is less than the cost of capital, you reject the project. If the IRR you get is more than the cost of capital, you accept the project. In our case, we have got 9.4%. If we go to our question, you will find the cost of capital for this farm is 11%, which is more than our IRR. Therefore, what do we conclude? We say reject the project because the IRR is less than the cost of capital. So every time when you are considering various projects, this time we have used the cost of capital. In other examples, you'll be given the firm's acceptable rate of return. Whichever the case, compare your answer with the rate of return given in the question, and you'll be able to determine whether to accept a project or reject. I may also need to add, if you get exactly 11%, then you become indifferent. You can accept or reject the project. The last method we are going to look at is the profitability index, which is commonly referred to as PI. PI here means the present value of cash inflows you divide by the present value of cash outflows. We accept a project if the PI is more than 1. Reject a project if its PI is less than 1. If PI is equals to 1, then use other methods. Or you can decide whether to accept or reject. Let us look at a simple example to illustrate how to use the profitability index. Now, a firm has an initial investment of $650,000, and its expected cash inflows are year 1, $150,000, year 2, $100,000, year 3, $220,000, year 4 is $180,000. You are required to determine the profitability index of the project using a discount rate of 10%. Then you advise the management whether to invest in that project or not. Now if you look at this one, you provide for columns like we did earlier on, but this time we do not have year 0 because we are only computing the present value of the cash inflows, since we already have the present value of the cash outflows. So once we have gotten this, we got the answer of 539.62. You divide by our initial cash outflow, which was 650,000. The answer you get is 0.83. Our answer is clearly less than 1. Therefore, we reject this project because the answer we have gotten is less than 1. If we could have gotten an answer more than 1, we could have accepted this project. That is the end of our presentation. Thank you. And
these televised lectures supplement our robust online learning going on our MKU online platform. You can view more on our televised lectures via our online platform. We are in a digital era, and Mount Kenya University knows this. The following are the steps to follow so as to complete your online application. Download the application form from the website www.mku.ac.ke. Attach copies of your academic certificates and ID. Pay the application fees via M-Pesa pay bill number 270988. Your ID is the account number. 2,000 shillings is the charge for a postgraduate. You can also deposit in the bank accounts provided on the website. Then email all the above to apply@mku.ac.ke.